Stardate 9/11/2020. Welcome everyone to the September meeting of the Memphis Astronomical Society. I'm your host, Jeremy Veldman. My crew members are off to dinner, so I'm holding down the bridge until they get back in a few minutes. But just wanted to take a time to kick off tonight's meeting. Hope everybody's doing well. Want to thank you for taking a moment to join us tonight. Tonight's presentation is on SETI, the search for extraterrestrial intelligence and the possible implications of making contact with extraterrestrials. Our presenter is Dr. Karl Leib, Associate Professor of Political Science at Christian Brothers University, and we'll get into his presentation in a moment. But before we do, just a couple preliminaries. First of all, we are the Memphis Astronomical Society, and we are a nonprofit public service organization promoting interest in education in astronomy and related sciences. Our website is memphisastro.org, and you can also find us on social media, on Facebook, Twitter, and YouTube. And if you haven't already, please take a minute to subscribe to this YouTube channel. Just recently passed the 1,000 subscriber mark, so I want to thank all of our subscribers over the years for tuning in and participating, and hope we get a lot of value out of tonight's presentation. Our website has some great information on it, including links on the left to, among other things, information on how to buy and set up a telescope, as well as how to align a Newtonian telescope, and then also a calendar of events. Now, we are still shut down officially due to COVID-19, so all MAS public outreach events and observing sessions are officially canceled. However, we have released a set of guidelines to follow, and we are monitoring the situation weekly. And as the skies clear and the weather cools and conditions become more favorable for observing in the fall, we're looking at opening things back up again. So we have done this a couple times in the past couple months. I want to personally thank everyone who came out for abiding by these guidelines. If you're on our email list, pay attention to your email. Look for notices from us for when we open things back up, and we'll send out these guidelines again. Again, all they're intended to do is just keep everybody safe as we continue to ride out the pandemic. But officially, we're closed down. Unofficially, we will get out and do some observing again, dark sky observing, and we'll send out the notices via email, and then also the guidelines. And again, just want to thank everybody for respecting the guidelines. We're nearing the end. We'll get through this, and things will get back to some semblance of normal again, hopefully soon. Now, we have had a couple of virtual star parties, and we're looking at doing another one again this month, September 26th. I believe it's the last Saturday in September. And again, this is a Tennessee statewide virtual star party where astronomers from all over the state log in via Zoom and show live feeds of objects through their telescopes. We've been a participant in this event for the last couple of months. We're looking at doing it again. It's not an MAS hosted event. It's actually hosted by Dyer University, or Dyer Observatory at Vanderbilt University. But the last one in August was really amazing. We showed the moon again, Saturn, Jupiter, and Pluto. I'd never seen Pluto through the eyepiece of a telescope. It was my first time. It was really cool to see that. And the Memphis Astronomical Society showed some footage from Burton Sugar Farm, our dark sky observing site, and several deep sky objects through the eyepiece of a telescope. I will post video footage of that on our YouTube channel sometime soon. But mark your calendars for September 26th. We'll send out a notice via email also, but we're looking at doing another Tennessee statewide virtual star party, again, toward the end of the month, probably September 26th. So stay tuned for notices regarding that event. If you're interested in joining our email list and you're not on our email list already, go into joinmas.com, enter your name and your email address. And again, we send out notices about once a week regarding upcoming events. So go to joinmas.com if you'd like to be added to our email list. And when you become a paying member, you get access to the Meteorite, which is our monthly newsletter. And the Meteorite has some great content, including articles from some of our current members, meetings from past board of directors, minutes from past board of directors meetings, an astrophotography gallery. We've got some guys doing some really exciting things in the realm of astrophotography. They post a lot of their images on our Facebook page, but we feature a couple of these images every month in the Meteorite, so check that out. and then also a sky map for the month, in this particular case, September. So one of the perks of being a paying member is you get access to the meteorite, which has some really great value-added content. So check that out. And for everyone tonight, if you're logged on to this call or if you're watching the recording, I will have links to these two documents in the description below this video. That, of course, is our membership application, and then also the September sky map. If you're interested in becoming a member, just download, print off, fill out, and email our membership application to us at memphisastronomicalsociety@gmail.com. Or if you don't want to fill it out by hand, just send us an email. Again, memphisastronomicalsociety@gmail.com, and we'll send you the membership application in electronic format, and you can just fill it out and send it to us. So look for links to these two documents below in the description at the end of tonight's broadcast. Space, the final frontier. These are the voyages of the Starship Enterprise. To explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before. Makes for an intriguing plot line to a science fiction television series or movie, but not exactly practical, economically speaking, to where we are today. Obviously, we would love to get to this point sometime in the future where we can build a massive starship and explore the galaxy, possibly making physical contact with other extraterrestrial civilizations, if they're out there and if they exist. But for today, we have SETI, the search for extraterrestrial intelligence. Literally talk, and talk is cheap. Certainly a lot cheaper than building a starship to explore the universe. Now, this assumes, of course, that there is extraterrestrial civilizations out there. We don't know. And maybe they're like us. They're evolved to the point where they are, technologically speaking, capable of manipulating electromagnetic radiation, sending out signals, and they're naturally curious, like we are, to explore the galaxy and see if there's anyone else out there like them that may be listening. That's what SETI is all about, searching for and listening for and looking for the evidence of possible extraterrestrial civilizations. Some type of signal that's not generated by natural processes, but is artificial, created by sentient beings. SETI, the search for extraterrestrial intelligence. Now, if they're out there, and if we ever make contact with them, what are the possible social and cultural responses to extraterrestrial contact? Our presenter tonight is Dr. Karl Leib, and he's going to be discussing that, along with outlining the Drake equation, the famous equation by Frank Drake in the early 1960s to estimate the possible number of communicating civilizations that could be out there. Now, Dr. Karl Leib is an associate professor of political science at Christian Brothers University, but he's had a lifelong fascination and interest in space. And Keith and I had a chance to sit down with Karl and briefly discuss his background, as well as the presentation that he's going to be giving you tonight. So without further ado, here is Keith and my conversation with Dr. Karl Leib. Welcome everyone to the September 2020 program of the Memphis Astronomical Society. Jeremy Veldman, I'm here with my buddy Keith Latulay, and we are privileged tonight to have Dr. Karl Leib, who is a professor, an associate professor of political science at Christian Brothers University in the Department of History and Political Science. And Karl is going to be giving us a talk tonight on SETI, the search for extraterrestrial intelligence. How you doing tonight, Karl?
Not bad. How are you doing?
Very good. Thanks for joining us.
Thank you for asking me.
Now, your talk is going to involve sort of a beginning overview of SETI, the search for extraterrestrial intelligence and related searches. And then also you're going to go into the Drake equation, which of course is the famous equation that Frank Drake crafted in the early 1960s to give us an idea of the number of communicating intelligent civilizations that might be out there in our galaxy. My question to you is, how does a professor of political science get an interest in astronomy? Kind of tie the link there, if you will.
Well, I was thinking about this earlier today, and I can't think of a time when I wasn't interested in space. Perhaps because I was growing up at the very tail end of the Apollo era, and in high school I saw the first shuttle launches, I've always been interested in space. And when I was in graduate school for political science, looking for a master's thesis topic and then later a dissertation, I realized that space policy was something I was really interested in. The politics of how these programs come about, the way that space is an international issue and a legal issue. So it emerged out of my interest lifelong in space exploration, and applying it to the political side.
Yeah, it's very interesting. I tell you, it's getting interesting now because there are multiple countries that are getting involved in the space race. And you think about the 3 missions that are on their way to Mars this year, 2020, and then also what looks like a multinational effort to return to the moon within the next decade, if not earlier. So, yeah, space law. We've had a talk in our society in the past on space law. You don't really think about it, but it's becoming an issue now, international law. So you've basically been interested in astronomy your whole life.
Yes, absolutely. I had a telescope in high school, and always been an active reader, and history of science, books on astronomy, always among my favorite reads.
Absolutely. Now, what got you interested in SETI, the Search for Extraterrestrial Intelligence?
Well, I've always been interested in all aspects of space. And when I developed my course on the political history of the space age, I try to cover as many different topics as possible. And as we get closer to the end of the semester, we get to some of the more speculative topics, things like space colonization and SETI. And I'm very interested in the possible social or cultural effects. And
Absolutely.
science fiction writers have explored this, filmmakers have explored it. And I find that a particularly interesting topic. And I think I was in 10th grade when the original Cosmos was on.
Yeah.
So Carl Sagan definitely influenced my thinking a lot on this. And so it's just sort of naturally grown out of these other interests.
Yeah, it's interesting. And I don't want to give away too much of your talk, but you go back to the 60s when Frank Drake and Carl Sagan were introducing this concept to us. I think they were pretty optimistic in terms of the number of potential communicating civilizations out there. I think in recent times, maybe we've amended that a little bit and shrunk it down to perhaps include other factors that were not in the original Drake equation, and come to a realization that maybe life in the cosmos is more rare, or at least the conditions for life in the cosmos are more rare than what they initially thought. So again, I don't want to give away too much of your talk, but it'll be interesting to see how that unfolds as you get into it. So Keith, did you have any questions? I don't want to dominate the conversation here.
No, it's okay. I sent a message earlier to Carl. I'm really interested. I just bought an acre of Mars with a Groupon for $35. And I'm really curious now that I've done it. The deed's on its way, so I'm sure it's up and up deal. And I'm just worried that if somebody steps foot on Mars first, am I going to lose my property, or what's the deal there? I don't know. Maybe you can answer that one in your talk.
I'm afraid I have to tell you that deed probably wouldn't be enforceable in any court.
No, not here, of course, but in
Well,
Mars, sure.
It's an old phenomena, actually, going back probably at least 20 or 30 years of people selling lunar or Martian real estate. And multiple people have sold much of the moon and Mars. I'm not familiar with the particular company. You sent me the one picture of it. But the biggest problem is for property rights require law. So in order to enforce your property rights, you'd have to go through U.S. court, which would imply that the United States had sovereignty over Mars, which it doesn't.
Yeah.
And there are a lot of other reasons why people who claim to own vast tracts of the solar system don't. primarily because there's no evidence that any of these folks have ever paid a single cent in property taxes or income taxes on property that they claim to own in outer space.
So you're saying I'm out $15, right?
Well, you have an attractive picture you can hang on the wall. It's a novelty gift, I think, is the way it's legally framed, legally presented. Much as you can buy blank diplomas from fictional universities on Amazon. I've seen those, or you could print one yourself. But
All right. I can't wait to hear more. So thanks very much. I appreciate you being here, and just looking forward to it. Thank you so much.
Thank you very much.
Well, with that, I guess we'll go ahead and turn it over. I don't want to give away too much more of the meat of the presentation, but without further ado, Karl, I'm just going to turn over the presentation to you. I know you got a lot of content to share with us on SETI, the search for extraterrestrial intelligence, and also how it relates to space law and some areas of your research in political science as the exploration of space continues. So without further ado, we're just going to turn it over to you at this point. And again, thank you for taking the time to join us tonight.
Most of us have had this thought while looking at the night sky. Is anybody out there? This question has been asked for thousands of years, but only in the past century has technology been available that might possibly answer this question. The search has been sporadic and sometimes furtive, fearful of ridicule. Yet dedicated women and men around the world have turned their minds to the question of life on other planets, towards the possibility of intelligent life on other planets. This quest is known as SETI, the search for extraterrestrial intelligence. Is humankind alone? Is Earth unique, an unbelievably rare fluke in a vast universe otherwise devoid of life? Or are we one of countless inhabited worlds in a galaxy teeming with life and civilization? A plurality of worlds or a lonely Earth? These questions are perhaps best reflected in the two quotations here. In the first, Ellie Arroway, Carl Sagan's scientist heroine from the novel and film Contact, jokes, "The universe is a pretty big place. If it's just us, it seems like an awful waste of space." An alternative perspective comes from Dr. Enrico Fermi, physicist, who famously asked his co-workers one lunchtime in 1950, "If the universe is full of intelligent life, where is everybody?" There are good reasons to take both the optimistic and pessimistic position seriously. While the universe is vast enough to hide many secrets, it has existed for about 14 billion years, Earth for over 4 billion years, which is surely enough time for someone to have stopped by for a visit. The bottom line is, we simply don't know, but we are developing ways to maybe find out. First, I want to clearly differentiate between two separate kinds of searches. There are worlds in our solar system that may have the potential to harbor some form of life. Many proposals have been made to go and search for that life. However exciting the possibility is, within our own solar system, whatever life that may exist is most likely to be very simple, perhaps microbial in nature, or perhaps something like the creatures found in and around Earth's deep ocean hydrothermal vents. The image here is an artist's concept of a submersible probe exploring the subsurface ocean of Jupiter's moon Europa, and, optimistically, finding it. Reality or fantasy? Only the future can tell. The most promising targets for finding extraterrestrial life in our solar system are Europa, along with Mars and the Saturnian moons Enceladus and Titan. Many probes have been sent to Mars, and a virtual flotilla of spacecraft are being planned by many countries. Some of them may find evidence of life. However, none have as of yet. Missions to the outer solar system are more complex and expensive, but are well within our technological capability. So we may, in the future, find life on some of these other worlds. But while this would be amazing, it would not be the intelligent life that proponents of SETI are looking for. The search for extraterrestrial intelligence is a far more ambitious project. It is a search for other thinking creatures like ourselves. It is a quest to find alien civilizations. Such civilizations, if they exist, would be deep in space, dozens, hundreds, or perhaps thousands of light years away. Because of the great distances involved, the search for alien civilizations takes advantage of the one thing that can travel at the speed of light: electromagnetic radiation. In this case, radio waves. If a signal is detected, we can, in principle, contact the senders using the same technology. It would be a slow conversation. A signal from a civilization 100 light years away would take 100 years to reach us. Our reply, if sent immediately, would take another 100 years to be received. We could also look for signs of super advanced technology, such as large structures orbiting sun-like stars. That could, and I emphasize could, be evidence of massive engineering works designed to maximize collection of a star's energy. This sort of shell around a star is called a Dyson sphere, after physicist Freeman Dyson, who first suggested the idea in 1960. Dyson spheres have appeared in numerous science fiction stories, and I'll talk later about an odd star that recently prompted exactly this kind of speculation. Is the search for intelligent life a one-way proposition? Leaving aside jokes as to whether humanity qualifies as intelligent, has Earth been discovered by someone else? Today, scientists are developing methods to study planets orbiting other stars, exoplanets. By studying the gases that make up the atmospheres of exoplanets, we may be able to determine if any of them harbors life similar to life on Earth. If this is within our capabilities, it would certainly be possible for alien scientists to do the same thing, considering that Earth has had an oxygen-rich atmosphere for something like 2 billion years. To anyone looking, Earth would have been advertising the presence of life for a very long time. This raises the question of whether anyone has ever visited. The only answer I can offer is that while it's not impossible, there is not a shred of evidence for it. Not in the geological record, not in the fossil record, not in prehistoric times, not in historical times. It is a fascinating idea, but until there's actual evidence, it's nothing more than an idea. What about humankind itself? Have we ever given a big hello to the universe? Actually, yes. For the past century or so, we've used electromagnetic radiation for our own purposes: radio, television, radar, and so on. Most of this would be too weak to be detected by any potential ET, but some radio, television, satellite, and radar transmissions of the past 50 to 60 years might be. In theory, someone within 50 light years of Earth could pick up our broadcasts. However, as the signals travel, they weaken. If an alien civilization around Alpha Centauri, the nearest star, was busy broadcasting with our technology, we probably couldn't detect it. But a more advanced alien civilization could possibly find us this way. In 1974, the only deliberate interstellar message ever sent was transmitted in a test of the then new Arecibo radio telescope in Puerto Rico. The brief message, written by Frank Drake and Carl Sagan, consisted of simple pixelated images representing the telescope itself, a human figure, and DNA. It was sent towards the star cluster M13, which is 25,000 light years away. The signal will take 25,000 years to reach M13, and 25,000 more for any reply to reach us, assuming there's someone there to reply. They needed to test the telescope, and they did it in a clever way, but this obviously was not a serious attempt at interstellar communication. The only other examples of deliberate human attempts to communicate with aliens, at least one-way communication, are attached to space probes launched in the 1970s. After completing their flyby missions to the outer solar system, the Pioneer and Voyager probes continued on separate courses out of the solar system. Pioneer 10 and 11 each carry a plaque depicting two human figures, a diagram of the spacecraft, and other information for any aliens that one day might find it. Voyager 1 and 2 each have a record on which was encoded sounds, music, and pictures. Will these spacecraft ever be found by aliens? Truthfully, this was always a very remote possibility. Even so, as fast as the Pioneers and Voyagers are moving, they won't reach the vicinity of another star for tens of thousands of years. So, while we've been accidentally signaling to the universe for some time, our deliberate attempts have been much more limited. However, humans have been thinking about life on other worlds for a very long time. The idea of other inhabited worlds is an old one. Ancient Greek philosophers pondered the question, as did medieval and early modern scholars from many parts of the world. Muhammad al-Bakir, fifth Imam of Shia Islam, who lived in the late 7th and early 8th centuries, is credited with this remarkable statement, where he strongly asserts that God created thousands and thousands of worlds and thousands of humankind. Al-Bakir's belief in a plurality of worlds is echoed by other Islamic writers of the Middle Ages. Drawing on their belief in an all-powerful God who created a whole universe, a seemingly infinite universe, it was logical that he would have created other worlds and other intelligent beings. Galileo Galilei and Johannes Kepler, much later in history, drawing on their Christian beliefs, came to very similar conclusions. So many people have considered the vastness of the universe and concluded that we are not alone. Giordano Bruno was an Italian philosopher and theologian. Among his many ideas about the universe was a strong conviction that the worlds visible in the sky must also be made of the same elements as Earth itself. As such, they must also be inhabited. He wrote, "All those worlds contain animals and inhabitants no less than can our own Earth, since those worlds have no less virtue nor a nature different from that of our Earth." Comparing al-Bakir and Bruno, I find it fascinating that two thinkers separated by time and by culture could each reach similar conclusions. The existence of life on other worlds came and went as a scientific or theological idea, but was widely embraced by writers of fiction. What better setting for social satire or imagined utopias than the moon or Mars? Some scientists, even into the very early 20th century though, thought that some planets in the solar system could be inhabited. William Herschel, today best remembered for the discovery of the planet Uranus, and who with his sister Caroline cataloged thousands of nebulae, took the plurality of worlds idea further than most. He wrote, "The sun is most probably also inhabited, like the rest of the planets, by beings whose organs are adapted to the peculiar circumstances of that vast globe." Herschel's ideas were a bit unconventional even for his own time, but it shows that the idea of life existing beyond Earth persisted well into modern times. While SETI as we know it today does not begin until after the Second World War, in the early 1900s, a new technology, radio, was quickly recognized as a means to answer the question of whether there was life on other planets. Radio pioneers Nikola Tesla and Guglielmo Marconi each proposed that radio could be used to communicate with a Martian civilization, if there was one. In 1924, American astronomer David Peck Todd, with the assistance of the U.S. military, lifted a radio receiver nearly 2 miles into the air while radio stations were briefly turned off. The goal was to listen for radio signals being transmitted by Martians. The experiment lasted 36 hours, but of course nothing was detected. While these speculations of Martian DJs may seem silly to us today, it should be noted that far less was known about the planets a century ago, and the idea seemed at least plausible to some scientists. These early examples of SETI would also inspire later, more sophisticated experiments. By 1950, scientists had long abandoned any hope of intelligent life anywhere else in the solar system, even though some thought there might be simple plant or animal life on Mars or Venus. Intelligent life beyond the solar system became the province of dreamers and the writers of fiction, but not entirely. A few scientists using more advanced radio telescopes began to listen for extraterrestrial signals. One of the earliest was Project Ozma, carried out by Frank Drake, using the 26-meter radio telescope at Green Bank, West Virginia. In 1960, Drake spent a total of 115 hours over 4 months listening to nearby stars, Tau Ceti and Epsilon Eridani. While Drake found no signs of artificial signals, it was the beginning of his lifetime of work in the field of SETI. Other SETI searches would be conducted later, and some continue to the present day. Of all the work done in SETI since then, there is one fascinating, frustratingly uncertain signal found by a SETI's project at Ohio State University in 1977. Scientist Jerry Ehman, reviewing the results, was so impressed by the strength of the signal, he wrote "wow" on the printout. To be clear, the "wow" signal was not a message of any kind. It was a strong, continuous radio wave. It was unusually strong and lasted for 72 seconds. Was the "wow" signal ET? Well, follow-up searches found no additional signals, and today the consensus is that the "wow" signal was probably generated by a terrestrial source, but no one can be certain. It has been this absence of any clear results that has dodged SETI projects ever since. Inspired by his work the previous year, Frank Drake gathered 10 scientists at Green Bank Observatory in 1961. Among them was a young Carl Sagan. This group, nicknamed the Order of the Dolphin by Drake, attempted to put into formal scientific terms the challenges they faced trying to detect extraterrestrial signals. This work became known as the Drake equation. Many components of the Drake equation are unknown, so the goal was not to create a formula that would magically tell you how many alien civilizations there are. Rather, it was intended as a framework for trying to figure out the answer to that question. This is the original Drake equation as devised in 1961. N equals R sub star times F sub P times N sub E times F sub L times F sub I times F sub C times L. N represents the number of alien civilizations in the galaxy. This number could be 0, or it could be in the millions. R sub star represents the rate of star formation. How many stars form in the galaxy in a given year? F sub P is the fraction of stars that have planets. Significantly, while this number was completely unknown in 1961, today thousands of exoplanets are known. Some exoplanets appear to be Earth-sized or slightly larger. A few may be warm enough for liquid water to exist on their surface. So planets, at least, are commonplace. N sub E is the average number of Earth-like planets per planetary system. F sub L represents the fraction of those planets where life actually develops. F sub I is the fraction of planets that develop intelligent life, that is, a civilization. F sub C is the fraction of civilizations that develop detectable communication technology, that is, the fraction that we could, in theory, actually talk to. L is the length of time a civilization transmits. This could also be interpreted as the life expectancy of a civilization. It's a difficult question to answer. How long does a transmitting civilization survive? 1,000,000 years? 100? How people fill this term in can, of course, vary. I suppose our pessimism or optimism about ourselves influences some of our assumptions about the longevity of alien civilizations. With the Drake equation, we at least have a roadmap to start with. But what exactly are we looking for? Might we hope to find a world at our own level of development? Keep in mind that the best radio telescopes in existence probably couldn't detect our own signals if they were coming from Alpha Centauri. We've only had radio for a little more than a century, so we are literally infants in the interstellar communications game. We're unlikely to find a less advanced civilization because they won't be transmitting. Given the distances involved, any signal we detect could be decades or centuries old, so it is most likely that if we do discover ET, they will be an older, more technologically advanced civilization. What that might mean for our relationship with them is anybody's guess. The Drake equation is not the only way to think about searching for extraterrestrial life. Dr. Sarah Seeger of MIT has developed a corollary to the Drake equation, which seeks evidence for life in exoplanet atmospheres. Oxygen tends to combine easily with other molecules, and thus an atmosphere full of oxygen would suggest that some process is constantly renewing it. Life is one such process. Seeger proposes using space-based observatories to examine the atmospheres of exoplanets. If a biosignature gas is found there, that would be strong evidence for life. Perhaps not intelligent life, but it would be a big step towards answering the question of, are we alone? Here is Seeger's equation. While it looks very similar to the Drake equation, it asks very different questions. N equals N sub star times F sub Q times F sub Hz times F sub O times F sub L times F sub S. N represents the number of planets with detectable life. Again, this does not imply that this life must be intelligent, or does it imply that it has technology to communicate with us. N sub star is the number of stars observed. F sub Q is the fraction of stars that are quiet, that is, relatively stable over a long enough period of time to allow life to develop. Many stars would have to be excluded from the search due to variability in brightness or energy output. F sub Hz is the fraction of rocky planets, something like Earth, in the star's habitable zone. The habitable zone is where it is not too hot and it's not too cold for life. Unsurprisingly, the habitable zone is also called the Goldilocks zone. F sub O is the fraction of such planets that are actually observed by our instruments. Much of our galaxy may simply be too far away or blocked by interstellar gas and dust for us to observe it clearly. F sub L is the fraction of planets that have life. And finally, F sub S is the fraction of such planets where life produces detectable biosignature gases. What does Seeger's alternative to the Drake equation get us? Primarily, it offers another methodology for the search, even if we may not be able to determine if the life discovered is intelligent or not. While it may lack the drama of a message of galactic wisdom from an alien super race, finding any life beyond the solar system would be a landmark scientific discovery. In addition, Seeger's equation is a reminder that the search for ET is not a stagnant project out of the past, but a vibrant science that embraces many different disciplines. There are other alternatives to the radio searches hitherto favored by SETI researchers. One argument for why we don't hear alien signals is that radio may be replaced by more efficient technologies, and it isn't actually used by advanced civilizations. It's analogous to the decline of AM radio once FM radio became commonplace. While it's pointless to imagine physics-defying technologies, there is one valid possibility: high-power lasers. Some SETI researchers propose looking for narrowly focused lasers rather than listening for radio messages. Another, more controversial proposal is known as active SETI, deliberately transmitting messages to likely candidate stars in hopes that someone answers. Some people, like science fiction writer David Brin, have condemned the idea of active SETI as reckless in the extreme. The consequences of such an action would be for all humankind, indeed for all life on Earth. What if the recipients turned out to be xenophobic or imperialistic? Why should we risk drawing attention to ourselves in such a direct fashion? Is active SETI too risky? The only honest answer I can give is that the risk can't be judged to be zero, and the stakeholders in such a project would vastly outnumber the participants. Does anyone, a scientist, a group of scientists, a billionaire, a corporation, a government, have the right to take such a step on behalf of Earth? Certainly, at a minimum, an extensive global debate should precede any attempt at active SETI. Before considering the consequences of discovering ET, it should be acknowledged that there is no scientific consensus on any of this. When Enrico Fermi asked in 1950 where all the aliens were, it wasn't a joke. He realized that even given the speed of light as a cosmic speed limit, if intelligent life arose just once in the billions of years the galaxy has existed, it would have time to colonize, or at least visit, the entire galaxy in just a few million years. You don't need a million civilizations boldly going where no one has gone before. You just need one spacefaring species and a fraction of the galaxy's history. So where are they? There's no easy answer to the Fermi paradox and its objection to the optimistic vision of SETI. We also know from the fossil record that life has been knocked about quite a bit in Earth's history. Mass extinctions caused by asteroid impacts are the least of it. Nearby supernovas and other astronomical events could routinely obliterate whole ecosystems. Life may get started on many worlds, but may not survive very long. A species' own aggressive tendencies could cause it to self-destruct soon after discovering nuclear or biological warfare. These filters could explain why the universe is silent. There were aliens, but they're all dead now. Earth's own history is a litany of chance occurrences. A lot of things had to happen precisely the right way for us to be here at all. It took 3 billion years for multicellular life to evolve, 500 million more for those clever humans to show up. That is a long time from planetary birth to stepping off into space. And why should we assume that it happens everywhere? It's possible that Earth is the result of a bunch of lucky breaks, a 1 billion to 1 chance that rarely happens. A given galaxy might see this happen only once in its history. Therefore, inhabited worlds would be extremely rare, distant in time from each other, and too far apart in space for communication to be possible. We might be all there is in the Milky Way. Finally, are we anthropomorphizing by assuming that intelligence must lead to tool use, and that tool use inevitably leads to radio telescopes? Perhaps most intelligent life lives quite happily composing epic poetry and doing calculus in their heads while never finding any need for tools or metallurgy or thoughts of space. The galaxy could be full of water-breathing super geniuses, but we won't find them if they never use radio. Assuming alien signals are discovered at some point in the future, what might the social or cultural consequences be? The idea of first contact with an alien species has been fodder for science fiction writers ever since H.G. Wells imagined a murderous invasion from Mars in his 1898 novel, The War of the Worlds. On the other hand, other fictional aliens, like Star Trek's Vulcans, bring friendship and aid to a troubled Earth. Of course, science fiction alien motivations can be quite, well, alien. In Octavia Butler's Lilith trilogy, aliens alter human DNA, add their own DNA to the mix, and they don't ask permission first. Like the search for ET itself, you can be optimistic or pessimistic about what happens after contact. Assuming we don't meet extraterrestrials face to face, which is a pretty safe assumption, what might happen just knowing that extraterrestrial intelligence exists? What would that do to humanity, to our societies and cultures? How would it shape our religions and philosophies? What would it mean for our politics? All I can offer are speculations, but I think that the responses to a positive SETI result would depend a lot on the circumstances. Mere evidence of an alien signal, in other words, a wow signal that was confirmed to be extraterrestrial in nature, but otherwise was lacking in any information, would excite a lot of people in and out of the scientific community. However, many other people might not care. An actual message with information that could be examined and potentially deciphered would generate a lot more interest and much stronger reactions across the board. The way the discovery was announced would also matter. Scientists working on SETI have drafted a series of principles, the SETI protocols, to establish guidelines for what to do in case a signal is ever detected. The protocols are relatively straightforward, calling for independent confirmation of any signal, followed by notifications to be sent to international astronomical societies, the discoverer's home country government, and the Secretary General of the United Nations. There are also provisions for information to be disseminated through mass media. So far so good, but the SETI protocols are informal arrangements that do not have the force of law. We really have no way of knowing for certain how the discoverers of a signal may act, or how the discovery itself may be announced to the world. Above all, the nature of the signal will determine how the public will respond. If there's no information to be decoded or understood, many people may lose interest. At the opposite extreme, a clear transmission of the complete text of the Encyclopedia Galactica, complete with translation program and a cosmic Google app, would obviously change human life forever. Of course, to be realistic, a SETI discovery is more likely to be on the modest side, and likely to be brief and probably undecipherable, rather than a formal invitation to join the Galactic Federation. Still, public reactions will depend a lot on how much actual information can be gleaned from an extraterrestrial signal. Obviously, initial reactions would vary. After all, there are nearly 8 billion of us, and no two people will react exactly the same way. Many may simply not care. You may have experienced something like this yourselves, talking about some recent astronomical news to family or friends who don't share your enthusiasm about close-up photos of Pluto or a transit of Venus. Many may simply deny the reality of the signal, rejecting it as a hoax or fake news. Our fractured internet bubble of a world would almost guarantee that some people simply won't believe it and will find kindred spirits online to reinforce that disbelief. Others may panic, channeling a century of alien invasion fiction and conclude that our planetary number was finally up. Actually, fear is a common reaction when confronted by something new or unusual, and there would be nothing more unusual or more unsettling than finding ET. Curiously, some would probably proclaim that they had told us so all along. UFO enthusiasts would say, of course, and take a SETI result as confirming what they always knew. Hopefully, many would embrace such a discovery with curiosity and wonder. Personally, I hope the majority of people around the world would react this way. But I live on Earth, so I honestly don't expect it. Most likely, we would see all of these reactions at once. Over the longer term, a discovery of extraterrestrial intelligence could have many implications for human life. It could help shape a broader planetary perspective. Knowing that other intelligences exist might help humanity find its own sense of unity. Our petty disputes might seem unimportant when we know that we are but one planet among many. Oddly, I think such a feeling could be driven by either hopeful or fearful assumptions about the alien's nature. Knowing that at least one other intelligent species exists can offer a boost of optimism. They survived, so can we. It might help motivate us to fix some of our problems, even if we don't get any assistance from the aliens to do so. Alternatively, the discovery of a really advanced civilization could generate massive culture shock or sense of futility. If we happen to find ETs with godlike abilities, we might feel our own endeavors to be irrelevant by comparison. How discovery of extraterrestrial intelligence might affect religious or spiritual traditions is complicated. I assume that these would vary greatly. Some traditions already embrace the plurality of worlds and might accept ET without any reservations. Others may reject the idea as blasphemous and false and accuse scientists of stupidity or fakery. There simply is no single religious response to extraterrestrial life any more than there is a single religious stance on any other issue or question. However, if a real conversation with an alien species becomes possible, I suspect that cultural information, including our religions and philosophies, as well as the aliens' religions and philosophies, would be an important part of that exchange. There are a few examples of what we could call false positives, instances where at least a few people thought alien intelligences had been discovered or had discovered us. It's worth looking at how people reacted in those instances because it offers clues as to how people might react to an actual discovery of ET. A slow news week in the summer of 1835 led to the publication of one of the wildest media hoaxes in American history. 19th century journalists were rarely shy about publishing outright fiction as news, but the New York Sun outdid itself with its articles about the Batmen of the Moon. The so-called discovery of life on the moon was attributed to Sir John Herschel, son of the famed William Herschel, who actually was working at an observatory in South Africa at the time. How many readers were fooled by the increasingly outlandish claims of cities and strange creatures allegedly seen on the moon by a new telescope is unknown. Eventually the paper moved on, but it never acknowledged the hoax. John Herschel himself was not involved in any way in this hoax, and at first he was somewhat amused by it. He got annoyed later because people kept writing to him asking him about the Batmen of the Moon. The readers of the New York Sun evidently found the reports interesting enough to keep buying papers, for a while at least. So what does all this tell us? Besides the reminder to always get your news from more than one source, it's reassuring that people in 1835 were intrigued rather than afraid or unsettled by the idea of extraterrestrial life. The same can be said for reports in the 1890s that a network of canals had been discovered on Mars. American astronomer Percival Lowell was entirely earnest in his belief that he could see linear patterns on the Martian surface that seemed to change at different points in the Martian year. Lowell wrote and lectured on his belief that the lines were canals built by a desperate Martian civilization to draw water from the planet's polar ice caps. Few other scientists took this seriously, and many couldn't even see what Lowell said he was seeing. However, the Martian canals did inspire H.G. Wells to write War of the Worlds, though Wells's Martians were far more menacing. However, other than inspiring generations of literature, the Martian canals don't seem to have alarmed anyone in particular or otherwise changed world culture. Perhaps the supposed canals were interesting, but too far away or too speculative to matter to most people. More suggestive is an event that looms large in American folklore, the notorious War of the Worlds radio broadcast of 1938. Actor-director Orson Welles, no relation to H.G., led his Mercury Theater players in a free adaptation of the science fiction novel. The radio play took the form of fragmented news reports about an alien invasion of the eastern United States. Legend, reflected in this New York Times headline, claims that thousands around the nation panicked, thinking aliens had truly invaded Earth and had marched on Manhattan. Orson Welles himself helped promote the idea, suggesting, if nothing else, the power of radio to influence the public. But did thousands of people really panic? Historians who've looked into the incident have concluded that perhaps a few dozen people truly thought the broadcast was real. Others, tuning in the middle of the program, may have been momentarily confused, but there's no evidence of mass panic, calls flooding into police stations, fleeing mobs, or evidence that anyone ran screaming into the night to escape Martians. Any anxiety produced by the broadcast probably derives more from the international environment of 1938, as the world rolled slowly towards World War II. Even so, the site in New Jersey, which Orson Welles picked for his Martian landing site, has embraced the honor, erecting a monument to the day Mars invaded Earth. Even if stories of panic were exaggerated by newspapers, and that exaggeration grew with the retelling, the fact is that some people did react with fear, which is a reminder that, aliens or no, unexpected events can fuel anxiety and even panic. UFOs, flying saucers, men in black, grays, abduction. Sightings of UFOs since 1947 is absolutely clear evidence of nothing, really. There is actually no good evidence that UFOs are in fact extraterrestrial spacecraft. Photos of flying saucers have never really been convincing, given how easy they are to fake, as this one was using a lamp. Many people may honestly, genuinely see something in the sky, but we can't automatically conclude that they saw alien spacecraft without some good solid evidence. As Carl Sagan famously put it, extraordinary claims require extraordinary evidence. All that said, the UFO phenomena has haunted SETI from the beginning, as many people conflate the two endeavors. Those who criticize or mock UFO enthusiasts sometimes drag SETI research in and brush it with the same negative labels. A bunch of weirdos trying to talk to Martians. What UFO sightings do tell us is that there are many different possible reactions to be expected if ET is ever contacted. Everything from fear to wonder, from indifference to worship. UFOs have inspired all of this and more. Certain astronomical discoveries have briefly suggested the possibility of ET. One such example is the discovery of pulsars in 1967. Jocelyn Bell Burnell and Anthony Hewish, the two scientists who discovered the first pulsar, jokingly called it LGM-1, Little Green Men. They didn't seriously think that they had discovered extraterrestrial signals, but at first they couldn't be 100% sure that they hadn't. The natural origin of pulsars was soon apparent, but the remote chance that they could represent a kind of alien super technology never generated any public reaction. Might the discovery of real aliens produce the same disinterested reaction among the public? Possibly. In 1996, there was a brief flurry of interest in a lump of rock found years earlier in Antarctica. This rock was in fact a meteor that analysis showed had originated on Mars. The exchange of material between planets and moons is not that unusual. Material tossed into space by objects hitting the moon are found on Earth. Images of the meteor produced by a scanning electron microscope suggested to some scientists that they were seeing the fossil traces of microorganisms, possibly Martian microorganisms. Other research has cast serious doubt on this conclusion, but in the summer of 1996, the media was abuzz. President Bill Clinton even gave a press conference about the findings. The release of the science fiction movie Independence Day a month earlier and the expected landing of the Pathfinder Sojourner mission to Mars the following July may have primed everybody to overreact a little to the news of the little rock from Mars. However, the reaction to all of this was wonder, a skeptical curiosity, and a desire to find out more. These would all be very good reactions to a SETI announcement. More recently, studies of a star known as Boyajian star, or Tabby star, named after American astronomer Tabitha Boyajian, has fueled a lively debate. The star's brightness seemed to fluctuate in ways that couldn't be easily explained by current models of stellar behavior or what we knew about planets and their orbits. There was soon speculation that the variations in brightness were being caused by alien-built megastructures passing between the star and Earth. Could an alien civilization actually be building a Dyson sphere? Well, other non-alien superscience explanations have been proposed, which are far, far more likely. Still, for those who heard about Tabby's star, the reaction was again positive, a sense of wonder, a skeptical curiosity, and a desire to learn more. The discovery of the first interstellar comets also could be classed as false positives. These objects come from outside the solar system, and their courses will take them back out again. The question perhaps inevitably arose: alien space probes? Perhaps that would have been suggested anyway, but the fact that the first one discovered, named Oumuamua, was a 100 to 1,000 meter long cylinder-shaped object reminded a lot of people, myself included, of the alien space probe in Arthur C. Clarke's novel Rendezvous with Rama. Was life imitating art? Probably not. While some serious scientists still think that it is possible that Oumuamua is some kind of alien artifact, it is far more likely that it is just a weirdly shaped comet making its silent, lifeless way through the galaxy. However, since we'll never see Oumuamua again, we'll never know for sure. But the reaction has been, again, a sense of wonder, a skeptical curiosity, and a desire to know more. So where does the search for extraterrestrial intelligence go in the future? Do we keep listening? I think we probably will. SETI programs are privately funded, and as long as enough supporters are willing to contribute, the search will continue. Do we deliberately send messages into space? No individual can answer that. All I can suggest is that nothing be done in regards to active SETI without an extensive worldwide debate. How do we prepare for the day a signal is heard? Well, greater scientific literacy is a good thing in and of itself, but certainly encouraging more people to educate themselves about the universe will make us better prepared if that day ever comes. In addition, a sincere discussion of human history and society is important as well. We need to better understand ourselves and improve the way we treat each other before we can be ready to encounter ET. Finally, what does SETI say about humankind, those tragic and wonderful children of Earth? I can only speak for myself, but I think SETI reflects the better part of us, the part of humanity that seeks to understand, that asks questions, that is prepared to wonder at the answers. It reveals the optimism of humanity and our ability to look beyond the moment and consider the possibilities. I'd like to end with this quote from scientist Dr. Jill Tarter, one of the guiding lights of the SETI movement and the inspiration for the character of Ellie Arroway in Contact. I don't expect extraterrestrial salvation. I don't expect them to tell us how to solve our problems. But the very existence of such a civilization should motivate us to figure out a way to solve our own problems. SETI may produce nothing, or it may change our world forever. However, we too have the power to do that ourselves. And I hope, whether we discover extraterrestrial intelligence tomorrow or not for 1,000 years, we will have the wisdom and the courage to prove ourselves worthy of that title, intelligent life. Thank you.
Thanks a lot, Karl. Excellent presentation on SETI. Really appreciate you taking the time to put that together. A lot of content, very value added. Just really, again, appreciate you taking the time to put that together for our group. If you guys have any questions for Dr. Leib, please enter them into the chat room right now. We'll stay on for a few more minutes. So if you have any questions or comments, please feel free to leave them in. I believe Karl's on live right now, so you should be able to answer any questions that you have. Or if you have any follow-up questions, if you're seeing the recording of this, just send us an email, memphisastronomicalsociety@gmail.com, and we'll make sure that we get any questions answered or any comments addressed. So with that, got a couple of announcements as we wrap up here tonight. First of all, I want to take a minute to recognize Eldon Morgan. Your application for the Memphis Astronomical Society was just approved literally a couple hours ago. So I want to welcome Eldon Morgan, one of our new members. We were going to announce this at the next meeting, but we figured we'd sneak it in tonight since the membership came in just before the broadcast. So Eldon, welcome to our group. Very happy to have you on board as a new member. You can see that the format for our meetings is a little unconventional from what we're used to doing, but we should get back to our live meetings again, hopefully sooner rather than later, and looking forward to meeting you in person, either at a live MAS meeting or observing session. But for now, Eldon Morgan, welcome to our group. Very happy to have you on board as a new member. And reminder, guys, if you're interested in becoming a member, I'll have links in the description below this video to our membership application. All you got to do is download it, fill it out, and then email it back to us at memphisastronomicalsociety@gmail.com, or just send us an email, memphisastronomicalsociety@gmail.com, and then we'll send you an electronic version of that membership application, and then you can just fill it out that way. And we'll also have a link to the September sky chart in the description below this video. So with that, I'll see if there are any other comments or questions. Yeah, appreciate everybody's comments. Yeah, Warp 3 is pretty cool. I'd recommend it. We're on our way to the next destination, searching for life in our galaxy the hard way. So with that, we'll just stay on for a few more minutes and address anybody's questions or comments, if anybody has any. And yeah, we'll just kind of wrap up tonight's meeting. Our next meeting is going to be the first Friday in October. And I think it's only 3 weeks away, so it's going to be coming up sooner rather than later. So make sure you mark your calendars for that. Also, September 26th, reminder, September 26th, that's the last Saturday in September, planning to do a virtual star party. So again, it's a Tennessee statewide event. So keep an eye on your email for that. And again, if you want to join the MAS, just go to joinmas.com. If you're not on our email list already, we'll add your name and your email address and send you updates. So with that, just going to go ahead and kind of wrap things up for tonight. Again, thank you to Dr. Karl Leib for an excellent presentation. We'll have a recording of all of this once the broadcast is over. I'll also include links to some of the cool scenes that you saw for this broadcast. So you can be able to see some of those scenes as well. There's some really, really neat channels out there. And yeah, we'll just stay on for a few more minutes if anybody has any other questions or comments. So again, thanks for taking the time to join us. I'm just going to hang out here for a little while, relax, and we'll see you guys next month.